In this lesson, I want to go over a few basics before moving on to the nitty-gritty of parallel lines and transversals. Understanding these concepts will really help you when we get to the sections. So what appears to be a straight line here in geometry is actually also a straight angle, and it's going to measure 180 degrees. Now this may be common sense to you, especially if you've used a protractor before. What gets a little tricky is that people forget that even when we tilt these lines or these straight angles, they still measure 180 degrees. So if I start with my original straight angle here, measuring 180 degrees, and I introduce another straight line or another straight angle, something interesting happens. And actually, you can label these angles that form 1, 2, 3, and 4. And we're going to give special names to some of these angles. I want to focus on 1 and 2. We call these a collinear pair. Notice that these two angles together make up our original line, our original straight angle, so we call them a collinear pair. They're with the same line. And the angles that measure those angles always is going to add up to 180 degrees, which makes sense because the two of them form a straight angle, so they must add up to 180 degrees. Now, if we know one of the angles is 50, we can simply deduce that the other one must be 130 just by some simple addition. Now let's bring back in 3 and 4 here, and let's look at a different collinear pair. Let's look at 50 degrees and angle 4. Well, like we said, this is a collinear pair, so 50 degrees plus angle 4 has got to add up to 180 degrees, so we can see, therefore, that angle 4 must be 130 degrees. Now let's look at our next collinear pair. We've got 130 degrees and angle 3. Well, again, these add up to what? To 180. So we can easily deduce then that angle 3 is 50 degrees. And finally, looking at our last collinear pair, you'll see that they already add up to 180 degrees. Now, hopefully you've seen a pattern here. You see those two 50s and those two 130s. Well, when we have angles formed by two intersecting lines or line segments like this, the opposite angles are called vertical angles, and they are always congruent for the reasons we just showed. So another pair of vertical angles formed here is the two 50-degree angles. So what I'd like you to do now is I'd like you to see if you can apply these new concepts in this problem. You're going to solve for x and y given the angle measurements you see here. So these are two lines intersecting. Think of the four angles that we just dealt with and what you know about straight angles, collinear pairs, and vertical angles. So please pause the video now and we'll review the answer when you're ready. Okay, welcome back. Hopefully you were able to get that x equals 20 and y equals 10. Let's quickly go over this. For the x, what I said is, hey, 6x and x plus 100 are vertical angles. And I chose that first because they both have the same variable. Well, since they're vertical angles, they have to have the same measurement, so they equal each other. So just by doing a simple bit of algebra, you can see we can move from the first line to the next line by subtracting x from both sides and get 5x equals 100. Then we divide both sides by 5 and we get x equals 20. Now we're going to use that value to help us find y. In the next problem, we can see that 6x and 6y are also collinear pairs here. So they're going to add up to 180. Well, I already know that x equals 20, so I'm going to substitute 20 in for x so that I get to the line that 120 plus 6y equals 180. We subtract 120 from each side, getting 6y equals 60. Divide each side by 6, and we get y equals 10.